Writing formulas and naming ternary compounds. Ternary compounds are compounds that contain three or more elements. All ternary compounds will contain at least one polyatomic ion. Our naming methods will be determined by the first element or the cation. The first step that we need to do is determine how to name the compound, is to determine what the first element is. Now, a word about our polyatomic ions. The definition for polyatomic ion is that a polyatomic ion is a group of covalently bonded atoms with a charge. Most of our polyatomic ions contain oxygen. If they contain oxygen, can also be called oxy, acid, anhydrides. For any of the polyatomic ions that contain oxygen, the most common form of it is given the ATE ending. The ATE ending does not determine the number of oxygens, and it does not determine the charge. It just tells you that it is the most common form. However, if you know the most common form, then you can determine the oxygens for any other ending with a polyatomic ion. So if our ATE ending is the most common, so let's look at an example here, and let's look at chlorate. Chlorate has the ATE ending, and its formula is ClO3, and it has a minus charge. So in the case of chlorate, the most common form of it has three oxygens. If we have chlorite, now we have the ITE ending, and an ITE ending means that it has one less oxygen than the most common. So one less than 3 is 2. So ClO2 is the formula for chlorite, and it has a minus charge. If we have a prefix of hypo and an ITE ending, that means that we have 2 less oxygens. So if we look at hypo, chlorite, so it has 2 less oxygens than chlorate. So 3 minus 2 would be 1. So ClO minus would be hypochlorite. And then if we have the per prefix and the ATE ending or suffix, then I have one more oxygen than the most common. So we can also have per chlorate, and that's going to have one more than the AT ending, or it'll be ClO4 minus. So when I sat down to memorize these many years ago, I memorized all of them that had an AT ending, and then I remembered these 4 little rules, and then I could figure out anything else based off of just applying the rules if I knew the name, or if I had a formula, I could work backwards and figure out what the name was based off of knowing the ATE endings. when we deal with naming groups for polyatomic ion compounds or ternary compounds, we're only going to look at groups A and B. There aren't any group C's that form ternary compounds, and acids is a separate beast that we'll look at differently. So again, group A is everything that's not in another group. Group B are the metals with multiple charges, the copper, chromium, cobalt, iron, mercury, manganese, lead, and tin. So our steps for naming these, very similar to the binary compounds. We name the first element, and then we name the polyatomic ion. We do not change the ending on a polyatomic ion. We just write it down as it is. So in my example here, NaClO3, Na is sodium and ClO3 is chlorate. So we just put those together and make it sodium chlorate. And then down on this second one, we have Mg is magnesium and CO3 is called carbonate. So my name would be magnesium carbonate. Group B, we still have to figure out what the charge is for the group B elements. And then we name the first element, and then we name the polyatomic ion. So for example, if we have FeSO4, so if we look at this, so SO4 has a -2 charge. Fe, we're not sure what the charge is, but if my overall charge has to equal 0, then what plus -2 is equal to 0? Well, that has to be a +2. So Fe in this case is going to be iron 2, and it will also be, iron 2 is also called ferrous. So we have iron 2 and ferrous, and then SO4 is sulfate. So we have iron 2 sulfate or ferrous sulfate. Now if we look at our second sample here, MnO4 has a -1 charge. So if my overall charge has to be equal to 0, then copper must have a +1 charge. So copper with a +1 charge is called copper 1, or it can also be called cuprous. And MnO4 is called permanganate. So that's copper 1 permanganate. Or cuprous permanganate. If we're going to write formulas with groups A or B, it doesn't matter either way. It's the same way to write the formulas. You take the name of the first element and give it a symbol. So sodium is Na+, hypochlorite is ClO. Since the charges are the same numeric number, we just write down NaClO. In the case of our second example, calcium chlorite, calcium is a 2 and chlorite is a -1, so we have to do our flip-flop thing, and so we end up with CaClO2 parentheses 2. We will put parentheses in around the ions if it gets a subscript after it. So if we look at an example here, sodium sulfate. So sodium is Na plus, sulfate is SO4 2 minus. So those aren't equal, so I got to do the flip thing. So I should end up with Na2SO4. Ferric cyanide, ferric is iron 3. So that's Fe3 plus. Cyanide is Cn, and it's a minus. So I've got to move the 3 out here and the 1 over here. So I should come up with Fe, open parentheses, Cn, close the parentheses, 3, which means that I have 3 Cn's. I have to write it that way. So calcium hydroxide, we have Ca, it's a 2 plus, OH, and it's a -1. So we're going to flip our charges, and we should come up with Ca, open parentheses, OH, close parentheses, 2.